The universe is made up of two types of materials, matter and energy. In chemistry, we are studying matter and its interaction with energy. There are three common states of matter: solids, liquids, and gases. The macroscopic properties are determined by the microscopic properties. So for solids, we have a definite shape with a fixed volume and a negligible compressibility. Of course, volume and compressibility go together. So compressibility has to be negligible for volume to be fixed. These properties result because the atoms and molecules of the solids are close packed. They're adjacent to each other. They're right up against each other. There's no room to push them closer together. And they are also in rigid location. They are in what we would say military formation. They can't move around. So that rigid location makes the shape definite. It cannot change shape because the molecules are not changing location. For liquids, we have an indefinite shape. The shape can change and flow, but the volume is still fixed and the compressibility is still negligible. So on the atomic level, the molecules are close packed. They are right up against each other. This creates the fixed volume and negligible compressibility. But in this case, they are in active motion. The molecules are moving. The motion of the molecules is creating fluidity in the macroscopic properties so the liquid can flow and the shape is indefinite. These two physical states, solids and liquids, are condensed states. Gas has an indefinite volume, it has an indefinite shape, indefinite volume, and significant compressibility. These result because in a gas, the molecules are widely spaced. Gas consists of molecules surrounded by mostly empty space. So we are able to change the volume and through compressing it because there's space between the molecules, so they're able to move closer together or farther apart. The molecules are in active motion, so this means that the gas is fluid, so it flows, and it can create new shapes. It fills the shape of the container it's in. For any particular material, for one material, such as water, we see that we find these solids at colder temperatures than the liquids, and we find the gases at hotter temperatures than the liquids. So we have this general range for all materials that the solid is found at the coldest temperature, the liquid at the intermediate temperature, and the gas at a higher temperature. The transitions between the physical states, we have terms for those transitions. To go from a solid to a liquid, it's melting. To go from liquid to solid, it's freezing. There's a heat component to this. So to melt something, it needs to absorb heat. And then to freeze something, it releases that heat. It will be the same amount of heat in both directions, but one's being absorbed to melt and one's being released to freeze. To go from a liquid to a gas, it's vaporization or evaporation. And then we have boiling, which is a special case where we have the gas formation in the liquid. These processes require heat, so they absorb heat to vaporize or evaporate a liquid. The reverse process of going from gas to a liquid is condensation. This will release heat. We have a couple materials that will go directly from solid to gas. This is called sublimation. This will absorb heat. So the common item for this is dry ice. Dry ice, which is solid carbon dioxide, does not melt. It will just sublimate into the gas. In the process, it will absorb heat to keep our food cold. The opposite process, going from gas to solid, is called deposition, and this will release heat. To melt a solid or to freeze a liquid, there will be a temperature that this will occur in both directions. That's called the melting point. This temperature, the melting point, will allow the solid and liquid to coexist in equilibrium if there's no input or removal of energy. But to melt a liquid, it will occur at the melting point, and to melt a solid, it will occur at the melting point, and to freeze a liquid, it will occur at the melting point also. So same temperature, both directions. This temperature has a pressure component. It will vary a little bit with pressure, but not much. The boiling point, the temperature at which a liquid will boil, this has a strong pressure component and will vary tremendously with pressure. The boiling point, since it varies with pressure, it varies with location. So the boiling point of water is lower in Denver than it is in Los Angeles. So often we talk about the normal boiling point. The normal boiling point is the temperature at which the liquid will boil at atmospheric pressure, which is at sea level with good weather. So if we were to take a solid and add heat, we'll see the temperature increase until it starts to melt. Once it starts to melt, the temperature will stabilize at the melting point. It will stay at this temperature when we have both the solid and liquid present. When we run out of solid, then the temperature of the liquid will start to increase again. The liquid will increase until we hit the boiling point, in which case it will continue to boil at that temperature. It will stabilize at that temperature until all the liquid is gone, and then if we continue to heat, the gas will get hotter and hotter.